Hello and welcome to another video on how to use C++. Today we're gonna work with pointers. So I already created a project named pointer and added a C++ CPP file. Then I already also included all our standard structure like include, using namespace std, and the main function with a return value. Also here is already a integer variable named a, which I assigned the value 5 to. Alright, so far we've only worked independently from memory addresses. We've only used the name of the variable, and only the program knew which memory address was behind the variable name. But with pointers, we don't want to work with variable names, but with the memory address itself. Okay, let's get started. We have our integer variable with a value 5, and we want to output this. So we write cout a has the value, and then a, and line. This is just the normal procedure. We run this and see, okay, the output is not very spectacular. It just says the value is 5. But if we want to have the memory address in the output, we just take this line and just edit it to a has the memory address, and then we use the ampersand to get the memory address. Run again, then we can see this little cryptic number here, which is the memory address. This is just a place where the integer is saved with a size of 4 bytes. We can also put this as a comment to say integers occupy 4 bytes in or on the memory. But this is not because of the value itself, but because of the memory address. So if we want to change the value via the memory address, we do that with a pointer. And how to create and save a pointer? Well, we say int, then an asterisk, then we choose a name, let's say p for pointer, and we have to add the variable name a, and then we can assign the address of a with the address operator again. Okay, let's put a comment here also. Save the address of a in PA. And this is just the creation of a pointer to the variable a. Well, the pointer also uses memory, but always only points to the address of a variable. And when working with other variables, strings, or objects with bigger size, sometimes it's more effective to use pointers, because if not, then we would always have to copy the variables, which is not very effective. So here we have our pointer to a, which we created to point to the address of it, and then we can add an output here that says access via pointer to a. And now let's just output the pointer. So we put an asterisk here, which is the dereference operator, and then just the name of the pointer PA, end line, and run. Then we can see in the output that this is 5. So in this line, we assign the address to the pointer, or the pointer to the address, and then in this line, the asterisk, the dereference operator, searches what value is written in this specific address. Now what happens if I delete the asterisk? And also let's change these letters because it couldn't be shown properly. Then we see again that it is only shown the actual address. So let's put the dereference operator back again. And in the next step, we assign another value to a. Let's say a equals 12. And then we just put all these outputs here again and run. Then we can see that how the value has been assigned to a, 12, and also our pointer with the dereference operator in combination shows us the value 12. Now let's add a second pointer. We just say int asterisk PA2, and then we say PA2 equals PA, which means then that both pointers point to the variable a. Okay, and now if we want to change our variable a with a pointer, then we just say asterisk PA equals plus equals 5, so the value should be increased by 5. And then let's output the value a again. And then we can see now the value has been changed to 17. Now we do the same with the second pointer. So we say that PA2 should be increased by 10. And then we have an output again. So now we can see in the output that first our variable a has been increased by 5, so to 12. And then the second increase, and we have the value 27. So with pointers, we have the possibility to access the memory address of variables at different positions in our program and change the value of it. This is important later when we are working with objects that have a certain size, and this advantage is then more obvious because if we move objects around, we don't have to work with the copies of it, but we can only access the specific values, properties, or attributes. If we want to initialize a pointer but still don't know where it should point to, it is important that we always initialize it with 0. So if we say another pointer asterisk p, if we don't do anything with it, it's very dangerous because the pointer could point to any memory address that may not even be relevant for our work. So pointers are very error prone. So we always have to initialize it with 0 or just say null. And then in the next step, somewhere in the program, we can assign, let's say, the address of our variable a again. So now we got a basic idea on how to work with pointers, but now I want to show you how to work with them in functions. So let's comment this out and collapse, and we create a new function. In the easy case, it's a function that increases a given value by 1. So we just name it add1 by value. And we assign a variable x, and then the return value is just plus x. So this means the variable has been increased by 1. To show that this works, we just create a new variable, an integer var that equals 1. And then we say in the output cout, the headline is by value, and then we have different outputs. First it says the value before the function call is, and then with a \t we set a tab, so a little space, and then we just say var end line. In the next line we want to output the value while the function is called, so we just say value while function call tab is, and then we can put the function right here, so add one by val of var. And lastly we have the output the value after the function call, so we just put var again, and then if we run this we can see of course our variable has been set to 1 in the beginning, then while the function is being called it is increased to 2, but after it's 1 again. So this means in the function we work with a copy of our variable, but if we work with a pointer the function works with the variable itself. So let's just add another function here. In this case we don't have a return value, so we type in void add one by ref, so this time we work with the reference, and then we assign a pointer int asterisk x, and then inside the function we type in plus plus, and then we have to add the dereference operator again and then the variable x. So don't forget the semicolon, and then we should write a comment here that we in this line dereference and increase at the same time. And then we can work with the function in the main and just take all these outputs again, paste them, and we say now we have by reference, so we make a comparison between the functions by value and by reference, but it's better to put 2 blank lines in here. Okay, so we have the value before, and while is not possible because we don't have a return value, so we just call the function, and then the function expects a memory address, so we assign the address with the address operator. And then the last line should be okay. We can now just run this. And then we see that, of course, before it was set to 1, but after we see that the value has been manipulated and has been increased to 2. Pointers can also be used to access elements in an array. So to see how this works, I'm going to comment this out again and collapse. Okay, so imagine we have an array with integers. Let's just take 10 values from 1 to 10. So just type in the array with 1, 2 till 10. And then if we want to output the array and just type in cout angle brackets array end line, then if we run it, you would normally expect to see the values of the array, but this is not the case. Instead, we see the memory address of the first entry of our array. So this is important. We don't see the values, but the address. So and now if we want to see the first value, then we should type in this, but with array of in square brackets of 0. So now we see the value 1. Okay, now what happens if we put the dereference operator in front of the array again? Before we had the address, and with the dereference operator, the value should be shown at the memory address. So if we type it in like this, it should be the first element of the array that should be in the output. And this is the case. So this means we can also increment an array. But let's put some comments first. So in this line, we have the address of our array element number 1, so value 1. And then in the second line, we have the actual value 1 in the output, as well as in the third line. So now how to increment this array? Well, we can do it like before with the for loop. So we type in for int I equals 0, then I smaller than 10, because our array has 10 elements, I plus plus, and then in the output we can just take this line, copy it here, and say output array of I. And if we run this, we can see that first we have the value 1 twice because we had it in the output before, and then we have the numbers from 1 to 10. Okay, but we can also do this with the pointer, with the dereference operator. So we just change this line to put an asterisk before our variable name. And then we open the brackets and say array plus I. Then we don't need this line anymore. We can comment this out. And if we run this, we can see again that we have an iteration over the whole array and have it in the output. Okay, this can also be done with pointers. Let's comment this out again and collapse. Okay, often we get the info about the size of an array only while it's already running. So for example, imagine we want to read values from a text file, but we don't know how many lines we have. And this can be very cumbersome when we have a very big document with many lines. Another example is if we want to read an image, but this image has different dimensions every time we want to read it. Let's say sometimes we have 800 by 600, sometimes we have 400 by 500 or something, and we want to write programs that can react very flexible. So this means if we want to read an image, the program should work every time and just can read every picture that we have, not only once. So then we don't have to change our code every time we want to read something different. And this is where dynamic memory management comes into place. Okay, imagine we have an array, but not defined as a variable, but with a pointer. So we type in int asterisk array. And because we don't have anything we pointed to, we first initialize it with 0. Then next we have a variable called n. And to show you that we can manage the memory in a flexible way, now the user should input the size of the array. So we just type in the output, please input the size of the array. Now we can use cin for the input of the user, and this should be n then. And now we can assign n to the array. So array2, and with the keyword new, we now reserve n values for the array, with n being the input of the user. And first we can initialize our array with 0, so we just type for int I equals 0, I smaller than n, I plus plus, we just set array2 of I equals 0. In the next step, we can work with the array just as usual, so handling of array2, like do some calculations or something. And then to empty the memory that has been reserved with new, remember to always do that. So always when we create some memory space, we have to clear it. We use the keyword delete. So delete array2, and also we have to initialize our pointer with 0 again. Okay, let's try to run this program. First we get asked the size of our array, so I can just type in 100 to save 100 values in this array, and then we can just work with it. And after that, the next step is that the memory space is cleared. Another good possibility is to do this with matrices. For example, if you want to work with digital images, because an image is practically just like a matrix with lines and columns. Okay, to test this, we define two integers r and c for rows and columns. And then we want to ask the user how big the image size is. So he should just input the number of rows. So it's asked to by a cout line. And the same for columns. So cout input columns. And then in each case, we type in the cin function for the input of r rows and for c columns. And to reserve memory for the matrix, we do it like this. So we first define an integer, a double pointer in this case, and name it matrix. So we put 2 asterisks and the name matrix. And this is, again, we use the keyword new and say int of r. Then next we iterate again, so we use for int I equals 0, and as long as I is smaller than the number of rows r, I plus plus, and in the loop we say matrix of I equals new int c. So what does this mean? Okay, first we reserved memory that is as big as the number of image rows and columns. And then for every entry, we also reserved an array of the size c. So now the matrix is a pointer to an array of pointers. And now we can work with this array as if it was a normal array. For example, we can assign 0 to every entry so that if it was an image, it would be a completely black image. And to do that, we have to iterate over the complete array. So first we iterate over the row. This means we type in for int I equals 0 as long as I is smaller than the number of rows are, I plus plus. And then inside of this for loop, we type in again for int. This time we need another control variable because we want to iterate over the columns. So we choose int j equals 0 as long as j is smaller than the number of columns c, j plus plus. And then inside of this for loop we can say that the matrix of I and j at this position should be 0. Then we can just work like normal with this matrix, as I said. So we can do an output here that gives us the value of the first entry of this matrix, so 0, 0, end line. And if we run this, then we are being asked for the number of rows. I'm just gonna say 600 here, and then the number of columns, let's say 800, and the console says that the first value of our image is 0. But we're not at the end yet because of course we have to clear the memory that has been reserved before. So we do this in an opposite order. So we first have to clear the rows. This means we type in for int I equals 0, I smaller than r, I plus plus. We say delete matrix at position I, and after that we can say delete matrix. And then if we run the program, then as usual we are being asked about the size of the image, so we just type some numbers, and then the 0 is the output, and after that the memory is cleared. So in this video, I hope you got an idea about what to do with pointers and what advantages we have with them. Later we are gonna have more examples how to use them, and I know pointers can be a little bit confusing in the beginning, but I hope this will be better later. So I hope you got a feeling for what's possible with pointers and that we're working with memory addresses and not with the values itself, and what advantages this has when we're working with functions. And also having the dynamic data management in mind, it's important that we now can make indications about how big an array or matrix can be during the runtime. So that's it for today, and I want to thank you for your attention.